Andy Badley. I'm the Technical Sales Director for NC Tech. The subject of this presentation is how we got to here from there. So it's basically, we're a panoramic camera company, and it's a little bit of the story about how we came to be. I thought you might be interested to find out. But first of all, who are we? Some of you know us, some of you maybe don't, so I'll just do a quick corporate whiz through. That's the basic background of what we are, what we do. And we are a company based in Edinburgh, in Scotland. Two co-founders, Cameron Ewer and Neil Tucker. That slide is now wrong, I think we've got over 40 staff now. Fairly heavily investment from both Scottish and independent investors, and there's our core IP. So we've grown quite rapidly over the years. It was formed in 2011. We had 2 staff. In 2012, I joined, increased the numbers dramatically from 2 to 3. And then, around about 2014, 2015, we launched the Iris 360 for the Google Street View. And that saw our numbers start to rocket. As I say, that's now out of date. I did that last week, and we're already up at about 40. So I'm just going to give you a little whiz through of our products. But it's not a product demonstration, but I just want to let you know what we do. This is one of our most important announcements that we made just the other week over in Tokyo at the Google Street View Summit. It's called iStar Pulsar. And it's part of one of the new Street View auto-ready cameras. And there's going to be another talk tomorrow, I think. Stafford, you're going to be given some more details about the new Street View program. So this is one of our products, and we're just about to get that out rolling. We're very excited for what that's going to do. We've also got this guy. I've actually got this on display on our booth, so if you get a chance, come and look at it. This is the new Iris 360 Pro. It's a 90 megapixel panoramic camera, and it uses the Google OSC API. So I've got that on the booth. Come and have a look. I don't have this on the stand, but I'm happy to tell you more about this. It's got our Lazarus. It is actually a LiDAR, laser scanner, but we call it a 3D reality capture camera. And it's got a laser in the center and a pair of our 18 megapixel sensors either side, and that allows us to capture laser scan data and colorize it all automatically. We announced something else at the Street View Summit. It's this guy. Oh, hello, that's gone a bit funny. So, this is our new VRC. We called it initially, I think, at the last Street View Summit, we called it the Iris VR. This is its new full name. We're really excited for what this is going to do. This should come out by the end of the year, and this will capture depth data up to about 15 meters and colorize it, and that's going to have a street price of between $500 and $1,000 US. So we're looking forward to see what that does. And all this is bound together by a hosting platform we're going to release called One Stop VR. You better upload all your content to it, not just from our cameras, any camera you like, any system. And it's an open platform with SDKs and APIs to hook into whatever system you want. So that's our products. As I said, I don't want to dwell too much on the products. But where did it all begin? So let's go back to 1988. I feel like I should do like a little wavy kind of pattern here with the music, but there we go. So it started with this, eTours, 1988, the 2 co-founders, Cameron and Neil. Back then, internet was young, we were all young. There's no Google Street View. So very few people understood 360 photography. And there was a lot of skepticism. You know, people would say, if you take a picture inside a house, it's going to promote burglary and thieves will come in. So there was a lot of resistance to what it could do. This was their early website back in the glory days in 1988. So obviously, websites have changed dramatically. This was their first piece of kit. Does anyone recognize what this is? No? Well, I was hoping someone did, because I don't actually know myself. I think it's a Be Here device, and that was their first kit. It wasn't digital, 35mm. They imported it from the USA. It was a double mirror, so there's a mirror in the top, and it took a photograph of the reflection of the mirror underneath. So quite a clumsy, complicated piece of kit. There was no preview, so you couldn't tell if you had it lined up properly. It was quite a lot of hit and miss. If you wanted to get your pictures, you had to take them down to Boots the Chemist. That's a UK shop for getting your pictures processed. So you had to wait till they came back. So it was, it wasn't an easy way of generating content. So let's move forward a bit to 2000. It was around about that time, maybe a bit earlier, digital cameras started to come out. So it allowed companies like eTours to put together complete packages. And so it made it much easier to get this content out, get content captured. So roll on a bit to 2003. Woo, full screen panoramas came out in 2003. So that was great. But the only problem was, the way the company was growing then, they needed to take a lot more images. And the equipment that they had just wasn't up to the job. So what do? The only thing you can do is make your own. So this is a little story about how you make a camera. So 2007, they started doing some tests of a double mirror system. There was a transparent shell to help protect the dome, and parabolic mirror, again taking a reflection from the top. So that went on, a little bit more design change. That rod came about a bit by accident, and the spike allowed us to remove 95% of reflections from inside the dome. So after that, you have to go through quite a lot of design stages. And these were some of the designs that they went through before they settled on the final design. And you have to go through a lot of iterations to get to what you want. So there's a few more designs here. And then eventually, they pretty much settled on what they wanted. This is called the VR station. That wasn't quite its final form. Its final form factor was that. No truth in the rumour that Darth Vader had a hand in the design process of that. But that was its final form factor. They pressed the top and the parabolic mirror popped out. So once they'd made that, happy days, we could start building them in numbers. And anyone else, I know there's a few manufacturers here, when you get to that point, it's a great feeling. And then of course after that, you get to start shipping. Happy days. So they made that, but they wanted something more rugged, more durable. We had a lot of interest from police and military. So they started work on what eventually became the iStar camera, which quite a few of you might already know. So this was it. I don't know about you, I kind of think that's a little bit too military myself in design, but that was an early prototype. But the thing is, 3D renders are all very well and good, but you can't actually get a feel for what the product's really like until you get it into your hands. And you can make 3D models, but then that was still a fairly embryonic process. So you can do pretty rudimentary stuff. And this was how this was how they could test the maximum footprint that they'd need for the camera. It's crude, but it works. So that's the kind of basic design work that goes into forming what the actual the model of the final design is going to be. So once we'd done that, we needed touchscreens, but I don't know if any of you guys are in the military or work with military and police. They tend to have big fingers, big hands. So we needed the touchscreen to be easy to use, very simple to control. So with that done, we then turned our attention to the design of the camera. And as you can see, we went through many different versions, but they wanted something special, something that didn't just look like another ordinary camera. So there was a number of design changes and options suggested, and these all were coming back from our designers. And this process goes backwards and forwards quite a lot. There's a lot of to-in and fro-in before you start to settle on the final design. And once you've done that, then you start working out the finer details. I don't know why in this picture it's so wobbly. I think, thankfully, the final design was a little bit straighter than that. But it gives you some of the notes that we put in as we were describing to each other how the shape of the camera is going to end up. And then, Google SketchUp. It's a good, easy-to-use tool. You can see how a small change to the little star shapes helped to make it look a bit more starry, whatever that is, instead of a more sort of melted shape. So all these tools were used to help finalize the design of the camera. So, and then, of course, touchscreens, we had to make sure they're bright enough to see in daylight. Then we had to calibrate the cameras. Now, I'm going to show you a couple of insider things here of how we calibrate our cameras. What do you do? Well, we thought the only way we could do it was to build a calibration room. And this is it. It's a 5-meter cube that was under construction. We then, no one's taking notes, I hope. 5-meter cube. We laser position the target with highly accurate lasers, and then that allows us to generate, that's the final calibration room with the target scattered across the surface. So that's how we calibrate our cameras. Move on, 2012, we launched the product. First time ever, that was us, Force of 3. We all looked a bit younger then. So that was the very first show in Houston. But the great thing about being part of a manufacturing company, you get to go to some great events like this. We went to Jordan, where it was a security military show. So we got there, and there's no truth that I've got a fairly aggressive sales technique, but you do get to play with some cool toys out there. So we get to do all these exhibitions, but I also get to travel a bit. And one of the things I've managed to do is try and take some photographs of the cameras in various places. So I'm going to show a couple of them to you now. This is an early camera we had. We started giving names to our cameras. So this was called RoboCam, because of its metal housing. Then we had one of the early designs for Iris. This was called PandaCam. So, and I just put this in, fisheye. Do you get it? That was in IVRPA in Vegas. So then, here's some of the more unusual marketing ideas we had, which thankfully didn't come to fruition. So we had an idea of a little mini NC Tech with this little camera. So we thought, what else could we do? We wanted to try and convey the size of the camera. So we thought we'd put them next to the camera. And then this next shot, I so have to show you this. I was lucky enough, I went to Mumbai, and if anyone's been to Mumbai, they'll know it's an absolutely amazing place. It's beautiful. People are so friendly. I was wandering around with my camera, and I went along the street, and there was all these stalls, and there was a chicken seller selling chicken. And I took a panoramic picture, but the picture just blew me away. So there's the chicken, but he's got a chicken on his shoulder. What's that chicken thinking? But it was an amazing place. Mumbai is absolutely brilliant. So anyway, that's a brief history of NC Tech and how we as a camera manufacturer go about building and making cameras. But if we move forward to 2017, we also had some new products. So I'm calling this section how to demo something you haven't made yet. So a couple of things that you can do. So this is the Lazarus, so it's a 3D render, but I'm sure some of you know this already, but you can easily add a bit of shadow to it. It looks a lot more realistic. And if you then drop a tripod on it, and then finally stick it in the scene, it looks like a natural product. And I mean, that's common now. That's how everyone gets their marketing of their products ready to launch before they actually have the physical product in their hand. Another example. This was the early model of what's now the VRC. So we had a 3D render of that. If you're wondering what those blue things are, they're Intel RealSense sensors that are on there. So then you mock it up. That's a motorized head that they'll spin on. And then, of course, you can make it look like you're holding the device. And indeed, you can then put it in a full scene. So that's it, basically. As I say, I just wanted to give you a little whiz through of our company and how the iStar came to be, and just a kind of a feel for what it takes to bring a product to market. So the good news is I've finished slightly ahead of time, so thank you, and any questions? Any questions?
1998, definitely.
Was it? I didn't do that slide.
Any questions?
Any other questions? No? Okay, thank you very much.
Short and sweet. Thank you very much, Andrew.
Well done.
Needs a mini display pod. Okay, I have one. Ah, here we have it. Oh yeah, please.
Okay, now we have Lutz Westermann, a brief introduction, creating VR experiences for the HTC Vive.
Test. Hello, everyone. So, my name is Lutz Westermann. I'm founder or co-founder of the company Hepto. We deal, today I want to speak a little bit about creating virtual reality experiences for the HTC Vive. So you might think, why specifically for the HTC Vive, and I want to give a little bit of an insight on this, because our main field of view is very specific. So we create devices that are used in exhibitions and trade fairs and museums, and there we deal a lot with the idea of creating interfaces to access information and media. So we can extend places or enrich them with modern media types. So in this field, so we have a few things to do. I can show you a little bit of an example. Oh. Sorry, we don't need sound right now. So here you see a little bit of what we normally do with interfaces on touchscreens. We want to make them simple to use and easy to navigate, so no confusion, pack a lot of information into it. And in this specific case, for museums, maybe we have the idea to extend a lot of pictures, behind-the-scenes material maybe, that are connected to some objects. So most of the time you take any museum and have an object, and what's lost is normally the story, the connections, the context, and how can we bring this back together. So in this example, it's a jawbone that is from one of our first human ancestors found in Malawi. And so we have here connected all the media into one device. So this is a project, a research project that we do with this Senckenberg Museum in Germany. And we try to think a lot about interface and a lot about creating, you see, interesting experiences at places where people meet. And so the next thing is, now the thing was, we always start with the hardware, and then we have the operating system, and then we have the layer of applications, and then on top we have media. So the next thing will be, when we talk about virtual reality, for us it was really important to find something that really fit into the situation, that when you go to a museum or an art show, an exhibition, or maybe on a trade fair, that it will really fit into this environment. And so we can really create a fantastic experience. And they're like, again, we start with the hardware, and we have here two devices that are acceptable in the quality. So, but when we go, there's a little bit on the history of virtual reality that's maybe important to understand here. So for the Oculus Rift, everything starts for the gamers. The main idea, the initial idea, when John Carmack presented the first prototype of this thing in 2012, it was really targeting the gaming market. The idea was you sit on your desktop computer, you put on the VR headset, and then you can play a game like Doom, and not much will change. You have a game controller, you have maybe, so the initial idea was also having all of these two pieces, but then they discovered a lot of little details about this concept of virtual reality. The first is like motion sickness or virtual reality sickness. This is a real issue. And this is connected to the point that you don't have, in the first iteration, you didn't have positional tracking. But in the moment when this idea went out and there was a little bit of hype, the idea came up to use maybe smartphones. They have also rotational sensors inside. So we have here a situation where we think there's very good experience to be created, but there are a lot of problems right from the start. So this concept still is today for the desktop users. So we have, they extended it after figuring out they need a positional tracking. They had put in this thing. So it's a little camera that can track the position by detecting infrared lights that are hidden in the VR headset. But this needs to be connected with a USB cable. And I think you can detect one Oculus Rift at a time. So the thing is, here at this point, the initial idea to start from the desktop with a sitting experience, looking at games that are maybe have to be changed a little bit. So this didn't really work out. So now they are selling these controllers where you can have more interactivity with the virtual reality scenario. But they had to keep a lot of things from the past. So you can still see they have the buttons from the controller, the A, B. So this is, and the, these little joysticks you can see here. And so there are a lot of buttons on these things, because this is what gamers need and what a lot of games are already produced. And you couldn't take this away. So this is a bit of a history of this specific device. And I don't want to say for the situation in an exhibition, when you hand out these kind of things, they look a bit complicated. So you would have to explain a lot about which buttons to use and so on. In contrary, HTC just, like this. So HTC just delivered from the first moment a complete feature set. We had the positional tracking, 2 simple controllers, and a few more things. And if you look closely to the controllers, so this is the first thing a user will interact with. You have this big button for the thumb, and you have mainly the finger trigger. So with these two things, you can do a lot of stuff. The big button here is also like a little trackpad. So if you need, you can get information out of this. So there are also grip buttons where you can grip things, but a lot of people don't use them. But it's not it's not a problem. So you don't think about these buttons when you don't want to use them. And now we have the lighthouses. The lighthouses are very cool because they are simply connected to the power. So we just can put them somewhere, and we don't need to connect them to the computer with a USB cable. So this is all like the magic behind the thing. But this makes it really simple and easy to put this into places. In contrary, when you have the Oculus Rift, you would need 3 of those cameras, and they would need to be connected via USB cables with a computer. This is just a little bit more, with the wires and so on. So we found this very simple and easy to use to put it in places. Then the headset itself, it's really, really modular, I would say. So we have, first of all, we have here on top, we have a little opening option. You can open this, and inside you will you will find a free USB port where you can plug in additional hardware if you need it. So also we have a little webcam here, so we can even make things like look-through experiences where we can see, okay, sometimes we want to have the image of this camera inside the VR in some way, so people can actually, see outside the headset without taking it off. And then there are also tiny other elements, like, one thing is if you have, for example, a trade show and you have every 10 minutes somebody putting on this set with the rubber straps, it's a bit annoying, but this new headset that comes up can be used with a Vive. You can combine it, and it's much easier to connect it to your to the head size by a little screw in the back. So these are cool developments, and we think that HTC is really looking forward to working on this for this business application type of thing, like having experience a lot of people don't have at home. And in the Asian market, for example, there are a lot of VR cafes equipped with these things because they are really suitable for this specific use case. So here we made our decision and said, okay, we go with a HTC Vive because it has also a little bit of a higher field of view. So the field of view is a very important thing for virtual reality, to feel inside. You have the horizontal field of view and the vertical field of view. And with the HTC Vive, you have like 110 degrees, and I think 90 degrees in the high. And the Oculus Rift is a little bit less. So this changes a lot the way you look at the media. But for us, it's very important to have, we see the VR thing as another way to access or interface information. And information so far is we have maybe 3D models created with like 3ds Max, Maya, Cinema 4D, and these kind of tools. We might have the idea of photogrammetry to capture real-world things and bring this in the VR. And then we have like 360-degree panoramas, like in stereo and mono, images and videos. And we have also stereo images that we can use in VR, and stereo videos that we can use in VR, next to audio documents and so on. So we can use the virtual reality space to really do a lot of things with material that we get from different sources. And our work normally starts with like somebody produces something, and we try to form then an interesting solution out of it. So, but there are very important technical details. So the first thing is to fight the motion sickness, which is really annoying if you don't keep track on these things. It's like we have 90 frames per second. So this is quite a lot to deal with. And you need to create your scenes in a way that they can handle this fast rendering. So the main thing is the displays in the HTC Vive and the Oculus Rift use both black between the image. So we have like 1,000 milliseconds, and then every 11.11 milliseconds a new image is rendered. This stays for 2 milliseconds, and then the screen will turn black. It's like a very fast stroboscope. And with 90 frames per second, you will not notice this. It's really important. And then we have forward rendering. Because we have these lenses, we need, we have these lenses that distort the image, first of all. So, and before the image is sent to the lens, before it enters the eye, the image needs to be distorted to, after distortion, the image should look right again. So in this process, we have normally a screen size like this. If you make it two halves, and you would then distort the image to this fisheye optics, you lose a little bit of space around. So this will require to make the large field of view that we need. We have on every eye. Now we make the image smaller, so then we need to resize it again, that it fits the complete screen. I don't know if I have it correctly now. But this is a point where we need good anti-aliasing, and this is connected to forward rendering, where everything is that we need, we have it there. So another thing is, in the VR world, we figured out people like details, because they go very close to things, and so we have to need bigger textures, more detail in objects, and so on. And this is quite a challenging task now, because we have to deal with the performance, and also maybe with like super sampling to get a clear and crisp image. And these things are all like technical stuff, and you can test it out a little bit, but this is real work to go through, to make test rows and so on. And the next thing is, if you have the media, you know what you need or what you want to produce, you have maybe the chance to select one of the engines that are available. And one of the big engines is the Unreal Engine, which is very famous for AAA games, and we have Unity, which is very widely used in this area. So I made a very quick tutorial. If you never opened Unity, it will look like this. So you can open up the Unity editor, and one thing is very cool. Even if you just bought the Vive and you don't know how to program anything, you can just start with a virtual reality project. There's a preset, a template, that you can select, and then you can just give it a name. And you can start exploring what they prepared. So you can maybe change things, you can put in your own models, and so on. So you have a good base to get started. One thing that's a bit annoying is that this scene does not really do anything. You have the play button that directly lets you play in VR mode when you put the headset on. But there's a map, there are different maps, and you find one map, this is in the middle down. It's a motion controller map, and there you have everything you need to get started in the first place. So one thing is, movement in VR is the best to use the teleporting idea, so which is here done with the arc that is automatically implemented. You can just navigate this way to go somewhere. They have also physics implemented. You have those two hands, and you can just start interacting and start a project. So even with no programming experience whatsoever. So this is one way that we can go. Right? There's not much coming. And Unity is a bit different. So when you have no clue how to do something, but you have the Vive and you can download Unity for free, then you create a project, same thing so far. But you have the process of getting your first world to run is also without programming knowledge. You can do it very quickly. So this is maybe the fastest tutorial to do this. They have the asset store, and you find there a lot of assets. And the first thing is you need the Steam VR plugin. This is a thing that Valve created. Then you download it, and then you have everything. So here is the point you click if you accept everything buttons to go further. Now, you have then this cage that you can just place into your scene. And if you now hit the play button, you have instantly virtual reality going on. So you have your headset, it will be tracked, you can put in objects and so on. Here we just, I just show here like a little bit like how the interface looked like when you want to have a ground and a few objects and the basic teleportation system maybe. So this is real simple to set up, and I think this is a really good thing so to get started, to look at your content and to figure out what will work and what not. And so the next step would be to get more advanced in this field, to get more, more things you can do with the controllers, more things to do with the technical things. We had this thing of like a video playback in Unity is like from start not really possible for VR. So you need specific tools. You will find a lot of help in this field. Also, very important topics are polygon reduction, retopo maybe, these kind of things. And one moment. So yeah, this is the last point. You just can add simply scripts that are prepared, like a laser pointer script and a teleporter script, and you just have to deal with a few settings, and that's it. In 3 minutes, you have your first virtual reality experience. So, but I guess a lot of people of you just work with Unity or maybe know these things. But I find it very good if the more people go into it and try it out, this will be just beneficial for everybody, even if we have exchange about this. So you can see here quite simple navigation setup. You just can click somewhere and you just jump there. It's maybe not the most ideal thing, but just to get a little bit of movement around and you know, do your first experiments. Now, there are two different business models. It's maybe something before you start working on projects. For the Unreal Engine, you have like 5% for Epic that you have to pay when you are like $3,000 above a calendar quarter. And Unity has a bit different options here. You can make up to €100,000 a year, and with the free version, and that's maybe important before you put in a lot of work and this will not work. So at this time, I have, I can show now a little bit of experiment that we did with virtual reality to showcase this on, for clients, for possible clients. So we played around with like a basic setup. This is how we started. We wanted to have a virtual reality template that we can use over and over again, so we can just interact with objects, can go close to them, and we just need to figure out what works well and what is a really cool thing and what will not work so well. And we find that gravity is not necessary, so not really necessary for objects to interact with, because this is really annoying when they fall down. You have to pick them up. So it's not with a headset on top. It's sometimes a bit complicated. So then we have animated objects. So we can do a lot of things that are very interesting, and this is really more interesting to look in virtual reality than now here in this simple video. But with virtual reality, we can also do a lot of things that we normally can't do. So we can give the things a size. We can explore different options here to make things visible that we in the real world can't do. And this is quite an interesting field, and we think it's worth to invest in this. So we can, with the modern technology, we can also do like things with like a flashlight and explore maybe something. And the cool thing is, since we also handle the hardware, we exactly know what we can do and how far we can go. Yeah, for this may be something different for the end consumer. We have made different experiences, experiments with photogrammetry. In this case, this is from yesterday, this crazy Austrian guy you met, Nikolaus Vukovic. This is his model. So, yeah, and he was so kind to lend me his VR set. So tomorrow we will build it up upstairs where the food area is. And so we can have a look at the examples if you want to have. And also Glenn Downing brought his Smithsonian 3D scans, so we can have this also, and I would like to invite you to this tomorrow morning, from tomorrow morning, and also on Tuesday. So if you're interested, just pop in, and we can have a talk about maybe technical details. I have only 3 minutes left. Maybe a few tips when you start developing stuff. Sorry. So one question was yesterday, when you have photogrammetry models, how to make a good retopo of them. So here's a tool that's called Instant Meshes. And this tool will allow to automatically retopo meshes. So this is it's a free tool. You can find it on GitHub for the Mac and the PC. And moment, I go a little bit forward. This video is too long for now. And so if you have kind of objects and you want to have a good mesh, then this thing can solve it for you. So just, there are a few simple options you can go through. And this is a quite nice helper, because for the virtual reality experience, we sometimes need really polygon reduction and to get rid of a lot of unnecessary polygons. And you see, it tries to, to assume where the squares could be, and you can get from this object. So this is maybe more interesting for people